Hi, and welcome to the Chapter 1 and 2 test review. Some of the problems that are on this test review I'm not going to cover on this screencast because they're just like the ones on the quest review, so you could just watch that and you'll know which problems they are. So we're going to move right ahead and go to the first problem I'm covering, which is number 3. This problem I know is actually on the previous, but I wanted to talk about this again because a number of people got it wrong, and it's such an easy one to get right. Pretend that this is the number line. Here are the positive numbers, negative, okay, so notice that the negative numbers from 0, the negative numbers go down. Going to the left, they're going down. They're getting smaller and smaller. But the absolute value of them gets larger. So everything to the left is smaller than the things to the right. Or everything to the right is larger than the things to the left. So we all know that 5 is greater than 4, for instance, or 4 is greater than 0. And we know that, say, 3 is greater than a negative 3. But then when we see these numbers, like negative 45 and negative 68, you could get the impression that this is greater. But it's not. You see, because the 68 is further to the left. The 68 is way down that way. So actually, negative 45 is greater than a negative 68, even though the absolute value of negative 68 and negative 45 would be the opposite way. The absolute value of negative 68 is greater than the absolute value of negative 45, but here we're looking at the actual value of the numbers. Evaluate the expression for the given value of x. Okay, we'll rewrite it. 2 minus 12 over x when x equals 6. Well, you just stick 6 in for x. 2 minus 12 over 6. So that equals 2 minus 12 divided by 6 is 2. So the answer is 0. So when you have this evaluate and then they give you the value of x, you just stick that value in for x. These variables are standing in for numbers, and usually we don't know them, and in this case we do. Translate the phrase to an algebraic expression. All right, the phrase is the difference between 11 times a number and 3. Let me make that a little smaller. There we go. Okay, so difference is a subtraction. When it says one of 4 things, difference, product, sum, or quotient, you put the number that comes first is the first one in that operation. So in this case, 11 times a number comes first before 3. So the difference between 11 times a number would be 11x, or some other number, some other variable would be fine, 11x minus 3. That's the difference. And if there's something else going on with this, like it was 12 times the difference, then you would put 11x minus 3 in parentheses and then put 12 times it. See, so for instance, if it said 12 times the difference between 11 times a number and 3, then I would have written it this way. Whoops, I wouldn't have written it that way. Hang on. God, why am I doing that? I don't know. I would have written it that way. Okay, but that is not the case. So I'll just erase it. Next problem, find the value of the expression. Well, this is an order of operations problem. So you do what's in parentheses first, right? And actually do these problems. I mean, like, turn the machine off now and do the problem on your own, and then watch me do it and see if you get the same answer, you know? Okay, so we're going to do what's in parentheses, and keep in mind that the fraction bar also is a grouper. So it's grouping the top and the bottom. So we have got the 6 minus 5 is 1. So I'll put that back in the parentheses. I'm going to copy everything else down. And same with the bottom. Okay, 8 times 1 is 8, plus 8 times 3. I wasn't supposed to do this one. 24. I'm supposed to skip these. Alright, too late now. Alright, 8 times 1 is 8. That's 32 divided by 8, because these were in the other. Oh well. 32 divided by 8 is 4. I wanted to cover this again, too. Find the following. The absolute value of 3. The absolute value of anything is how far is it from 0. You know, how far is it this way from 0 or this way from 0. So 3 is right here. So the absolute value of 3 is 3. Negative 12.5, let's see, that would be somewhere way over here, right? 12.5 would be out here somewhere. So it'd be negative 12.5. So that would be 12.5 from 0. So 12.5. Absolute value is always a positive number. The opposite is something else. Opposite is the opposite number. So 6, for instance, the opposite of 6 is a negative 6. Right? The opposite. If you add 6 plus a negative 6 together, you get 0. So that's what happens when you have the opposite. Additive inverse. You add them together, they become 0. So the opposite of 28 is a negative 28. The opposite of negative 28 is 28. Notice the difference between what is an absolute value and what is an opposite. They're two different things. Sometimes they turn out the opposite of negative 12.5 is 12.5, but the opposite of 3 is not 3, it's negative 3. See, so it's not the same thing as absolute value. Absolute value is how far you are from 0. Opposite is the number you can add to this number to get 0. And we use the opposites all the time when we're solving equations. Number 12, simplify the expression. So we're going to put this in the simplest terms we can. So we have to solve what we can solve. Alright, so we have two distributions here. We've got this one, would be negative 3 times 6r, and then we have a negative 3 times 5. So we'll start with that one. Negative 3 times 6r is 18r. Negative 3 times 5 is a negative 15. Okay, negative times this is a negative too. Negative times positive is a negative. Okay, now we've got the other one to do. 10 times 3r, and then 10 times 6. 10 times 3r is 30r. 10 times 6 is 60. Now we're going to combine like terms. And the like terms, as you can see, are the two r's and the two constants, the two numbers. We can't combine the numbers with the r terms because we don't know what r is. So now here, if you're starting to see all of these as signed numbers rather than, if you see it as negative 18r minus 15 plus 30r plus 60r, then you've got to do the we still have, in this case we really need to see them all as signed numbers so we can move them around. If they're all signed numbers added together, we can move them around using the commutative property. So that's what I am going to do. I'm going to put the negative 18r plus the 30r together, and then I'm going to add that to, I'm putting the parentheses in just for keeping things separate, 15, negative 15 plus 60. Okay, so I can combine my negative 18r plus 30, we subtract them, and keep the sign of the larger number. So it's 12, sign of the larger number is positive, so it's 12r. Okay, and then the other one, negative 15 plus 60, we subtract them. So we have, and you can do that on the side, you don't have to do it in your head. It's 45. Now then we look at the numbers, the absolute value of that and the absolute value of that, and we see that this one is bigger. So we keep the positive sign. Okay, so that's plus 45. And that's done. There's no combining that 12r and that 45r because we don't know what r is. R could be a billion or it could be 1. So there's no combining those two. We're done. Don't do more. Don't feel that you have to get rid of these r's and just end up with a number for an answer, because you'll get it wrong. Okay, we're going to start solving equations. Now the directions, first directions say solve the equation, give integer or fraction answer, state if no solution or infinitely many when appropriate. So basically we have to keep an eye out for the three possibilities. Generally we're going to get one answer, right? But sometimes it'll be an infinite number of answers or no solutions possible, right? Remember, infinite number of answers are, you get that when it's like x equals x or 5 equals 5, something that's equal on the other side, so that no matter what you had put in for x, it would have come out to be equal. It wouldn't matter. And then there's a situation where you have like x plus x equals, that's not what I wanted to say, x plus 5 equals x, or you'll have 6 equals 5, or 3 equals 0, something like that, things that are impossible. See, because no matter what you, in the equations that turn out to be like this, no matter what you would have put in for x, nothing would work. Like in this one, this would be previous to, if we subtract out the x's, we'd have 5 equals 0. So there's nothing you can put in for x here that it's going to work. If you put in 1, it's 1 plus 5 is 6, and 6 is greater than 1. There's nothing, even put 0 in for x, you're going to have 5 equals 0. So, no solutions. This is infinite, or we're going to have one solution. So we'll do this problem. Now, we want to get since the m is our variable, we want to get the m alone. So what can we do to make the m alone? Stop it and see if you can figure that out. Start it up again, and we see that we can add 13 to both sides. So we have negative 30 equals m minus 13. We add 13 to both sides. We get 30 minus 13 is 17. And is it a negative or positive? It's negative because the 30 is larger than the 13. We subtract the positive 13 from the negative 30 and we get negative 17. And that equals m, because these two 13s cancel each other out. It becomes m plus or minus 0. So that's our answer. That's one answer, so we don't need to say anything. So we're going to keep that in mind for all of these equations we're going to do. We're going to do a whole bunch of them. Okay, so that last one was a additive property of equality that we used. And now we're going to use a multiplicative property of equality. What can we do to get the a alone? A equals something, a positive a. Well, we can divide both sides by 8. So let's do that. 8 divided by 8 is 1. You see, you divide the numbers by the numbers and the letters by the letters. You don't have any letters here, so just the numbers. We'll divide those two numbers. And we get 1a, or just a, and on the other side it's a -3, or a equals -3. And we can prove this, that this is the right answer. So when you're doing a test, you should always, unless it's a really complicated problem that would take you a half hour to prove, you should stick the -3 back in for the a and see what you get. You notice we put -3 in here. -3 times 8 is -24. And again, one answer. So just need to keep that in mind.